Hello everyone, and welcome to today's webinar. The focus of today's webinar is on the selection and installation inspection of pavement markings. On behalf of the Illinois Department of Transportation, I'm Carmen Dwyer with Applied Research Associates, and I'm pleased to be your moderator for the webinar today. For a little background on myself, I'm a civil engineer and a University of Illinois grad. I've been with ARA for 12 years, and I'm presently a senior engineer and group leader within our research group. Of relevance to today's webinar, I was the lead principal investigator for the 4-year research project that culminated in the pavement marking selection and inspection guide that's being presented today. Before we get started, I would like to go over a few items so you know how to participate in today's event. When you joined today's webinar, you selected either phone or computer audio. If for any reason you would like to change your selection, you can do so by accessing your audio pane in the control panel. There are 2 ways you can participate. You will have the opportunity to participate in 5 polls throughout the webinar. Please make your selection promptly, and we will publish the results for everyone to see. You also have the opportunity to submit questions to today's presenters by typing them into the questions pane of the control panel. You may type in your questions at any time. We will address all of them during the Q&A session at the end of today's presentations. So now for our first poll. The first question is, what is your affiliation? And your choices are Illinois DOT, the FHWA, local government, contractor or consultant, or another affiliation. Please select the appropriate response and click Submit. And once we have most participants responding, we will publish those results. So here you can see we have a distribution between Illinois DOT, local government, and contractor consultant. Pretty equal distribution here between the 3. So our next question is, what district are you in? So are you located within the District 1 area, 2 or 3, 4 or 5, 6 or 7, or 8 or 9? This kind of helps give us an idea of the regions within the state that our participants are from. And I got a majority from District 1 and a fairly good distribution between the other regions of the state here. And our last question, how many times have you selected a pavement marking material type for a striping or construction contract? Choices are never, 1 to 10 times, or more than 10 times. Please select the appropriate response and click Submit. This question helps us give our presenters a little bit of background on our audience today. Okay, so we have quite a few folks that have quite a bit of experience. Still some others that have done or a little bit. So thank you all for participating in our poll questions. And we have just one more announcement, and that's before we dive into the webinar. As a benefit of your participation today, PD8 certificates will be provided via email. You will receive the amount of time you stay on the call as your credit. Only those participants who registered online will be eligible for a certificate. You can expect these in your inbox within about 1 week. So for today's agenda, I'll begin by introducing our 2 speakers, Kyle Armstrong and Anna Godina. Kyle will give his presentation on selecting pavement marking material, and then Anna will give her presentation on pavement marking installation inspection. Then I'll conduct the Q&A, and I'll wrap up with a couple closing details. And now I'd like to introduce both of our speakers. Our first speaker is Kyle Armstrong. Kyle is a graduate of the University of Illinois, where he received a bachelor's degree in civil engineering. He has worked at the Illinois Department of Transportation for 17 years, mostly for the District 6 office in Springfield as a traffic signal engineer and traffic operations engineer. He is currently the acting engineer of traffic operations for IDOT's Central Bureau of Operations, where his duties include developing policies, procedures, and programs for the installation and maintenance of traffic control devices, including pavement markings. He is also responsible for reviewing proposed traffic laws and regulations to ensure the safe, economical, and efficient operations of the highway transportation system in Illinois. He is a licensed professional engineer in the state of Illinois and is a certified professional traffic operations engineer through ITE. Our second speaker is Anna Gadina. Anna is a graduate of Bradley University, where she received a bachelor's degree in civil engineering. She has worked for the Illinois Department of Transportation in District 4, Peoria, for 16 years. The last 3 years, she has been the traffic operations engineer for the traffic section of operations. Her position includes creating pavement marking maintenance contracts for the district, and she chooses what pavement markings should be used on all construction contracts. And now I'll hand the webinar over to Kyle.
Okay, thank you, Carmen, and thank you everyone for joining the webinar this afternoon. I'm going to be discussing the research that was conducted which evaluated different pavement marking materials, as well as developed the recommended selection tables for those different pavement marking material types. So a little bit of background information regarding the research. Pavement markings provide critical information to motorists, and with a wide variety of marking materials available, choosing the material that best meets the needs of the public can be a challenge. So in December of 2009, IDOT commenced a 4-year study to evaluate a broad spectrum of pavement marking materials placed at several test sections throughout the state of Illinois. The project was awarded to ARA through the Illinois Center of Transportation, and the title of the project was Evaluating the Compatibility, Durability, and Visibility of pavement markings on various pavement surfaces. The primary objective of the study was to use the measure performance data that we gathered from the field installations to create a matrix of optimum and recommended pavement marking material options given the different site conditions. Now, when we refer to an optimum pavement marking material, we're talking about a material that is compatible with the site and the surface type of the pavement, a material that provides an appropriate service life, and also a material that is cost effective. So as part of the research, we evaluated 6 different pavement marking material types, and those included paint, thermoplastic, and tape. And when we refer to tape, we are actually talking about preformed plastic. So it would be listed as preformed plastic in the recommended selection tables and also in our IDOT spec book. We also evaluated 3 different durable and plural component marking systems, which included epoxy, polyurea, and urethane. So when we refer to a plural component system, that is a marking material that consists of 2 liquid products. One liquid product consists of a resin or a pigment, and the other liquid is the activator or binder for the marking material. And these 2 liquid products are mixed together in a specified ratio just before the marking material is actually applied to the pavement surface. And oftentimes the plural component systems are more durable and are expected to have a longer service life than standard traffic paint. Okay, so when we got the different pavement marking materials selected, we also needed to select the various test site locations throughout the state. And there were several variables that we needed to consider so that we could ensure that we were evaluating all the different pavement marking materials in different conditions. So there were 5 different variables that were considered for selecting test sites for the research. Those consisted of traffic volume, climate, contract type, pavement surface type, and the type of pavement marking application. So for traffic volume, we wanted to test the different marking materials in both high volume and low volume conditions. And as part of the research, we set that threshold between high and low ADT as 7,000. We also wanted to test the different pavement marking materials in different weather and climate conditions. So within the state of Illinois, the northern regions generally receive more snowfall than the southern regions. So we wanted to account for this. So the map you see to the right of this slide, the contour lines show the average number of snowfall days that the different parts of the state receive on an annual basis. And as you can see from the contour lines, the line that designates 10 snowfall days actually falls along the I-80 corridor. And the contour line for 6 snowfall days actually falls very close to the I-70 corridor. So when we develop the 3 different climate regions of the state, we have Interstate 80 dividing the north and the central regions of the state, and I-70 is the boundary for the central and the southern regions of the state. So test site variables were also developed based on the contract type. We wanted to separate pavement marking materials that were applied as part of new construction, which means it was new material applied to a brand new pavement surface, and also for maintenance striping, which is part of our statewide annual maintenance striping program. And this can either consist of applying marking onto an existing marking that's somewhat faded, or it could consist of actually removing an existing marking and then reapplying a new marking onto the existing pavement surface. We also select the test sites based on the surface type of the pavement itself. So we had test sites for both asphalt and for concrete. And then we also divided the test sites by application type, whether the pavement marking was applied directly to the final surface of the pavement or if it was actually recessed, which is shown in this picture on the right side of the slide, where you actually grind a recessed slot into the pavement and then apply the marking material into that recessed slot. So that way the entire thickness of the marking material is below the final surface of the pavement and helps increase the durability and expected lifespan of that material. So in the winter and spring of 2010, the research team identified numerous maintenance and construction contracts that met the desired test site criteria for each of the marking material types. So in the table shown here, the cells that are highlighted in gray represent the desired evaluation criteria for each of the marking types. Now you'll notice that some of the marking types are not included. So say, for example, we've got tape or the preformed plastic, which is not listed for surface application. It's not recommended that you apply tape directly to the final surface. It's a material that either needs to be inlaid into a hot asphalt surface or it needs to be recessed. So that is an example of certain situations where we did not test certain marking material types with some of the variables that we use to evaluate for the research. So for the test sites, there were a grand total of 66 test sites selected based on the 5 different variables that were included. The Illinois Tollway did contribute 15 of the test sites for the Northern Illinois test region. Okay, so we got our pavement marking types developed and we also got our test sites selected. So we needed to determine a way to actually evaluate how well these pavement marking materials performed in the field. And we ultimately developed 2 separate metrics to measure this. The first metric was retroreflectivity. So with retroreflectivity, you're measuring how visible the pavement marking is during both day and night. So whenever we apply a pavement marking material, we also include reflective elements or glass beads. So that way when there's a light source that is shined upon those glass beads, it takes the light and reflects it back towards the light source itself. So as you see from this slide, at nighttime, whenever the light from a vehicle shines forward, it hits the glass bead, and the glass bead is engineered so that it reflects the light back towards the motorist so they can more easily see the pavement marking. So the device you see towards the right of the slide is the actual device that was used to measure the retroreflectivity of the marking materials in the field. For the second metric, we wanted to measure the presence of the pavement marking materials. So when we say presence, we mean the actual percentage of marking material that is still present on the pavement surface itself. So for this metric, ARA developed a procedure where they were able to take a photo box, place it directly over the pavement marking material, take a photograph, and then analyze that photograph using their mark analysis program to determine the percentage of the marking material that was still intact on the pavement surface. Okay, so based on the two metrics, the retroreflectivity and the presence, a pavement marking index was developed just to create a single number or a singular gauge to determine the effectiveness of the pavement marking material. A PMI threshold of 60 was considered to be the marking's end of service life. So in this particular graph, you see all of the test site locations that contained thermoplastic material on a new surface. So based on these test site locations, we can reasonably say that thermoplastic should have an anticipated service life of over 3.5 years. Now for purposes of the research, we were somewhat conservative and used 3 years. But as you can see from the graph, the worst performing test site was actually well over 3.5 years. This is another PMI graph. This shows the various PMI values for the test locations where we installed urethane on maintenance project. So again, based on this graph, we can reasonably anticipate the service life of urethane on maintenance contracts to be 3.25 years. Okay, so we were able to take all of the test sites and all of the different pavement marking materials and determine the PMI values for all of those. And then with all the PMI graphs, we were able to determine the anticipated service life for every pavement marking material. Furthermore, we were able to take the unit cost data for several of the pavement marking materials to calculate an annualized cost. And also for the pavement markings that were recessed, we also included the cost of cutting the recessed groove in the pavement into that annualized cost. So based on the anticipated service lives and annualized costs, we were able to develop some recommended pavement marking selection guides, and we created 4 separate selection matrices. There's one for striping on new asphalt, striping on new concrete, and then maintenance striping on asphalt and maintenance striping on concrete. Okay, so this is an example of one of the actual selection guides and one of the actual recommendations. So again, based on the variables that we use to select the test sites, those different variables are also listed on the selection guides themselves. So as you can see from the selection guide, we have it divided up into 3 categories: the northern region, the central region, and the southern region. And then furthermore, the selection guide is divided from each of the 3 climate categories for low ADT and high ADT. And again, that's based on an ADT value of 7,000. Okay, the selection guide also is divided based on surface application and recessed application. So based on these variables, you see a list of all of the potential pavement marking materials that could be used for a particular application. So for this particular example, this list shows you the different pavement marking materials that could be used if you were in the northern region of Illinois on a high volume highway. And then the different pavement marking materials are listed in order from top to bottom based on the lowest annualized cost to the highest annualized cost. The numbers you see next to the different pavement marking materials show the anticipated service life of the material and that actual annualized cost data. Also, these costs were based on the installation of a 4-inch wide pavement marking line. So again, this would also be an example of the different pavement marking materials that could be used in the northern region of Illinois for a high volume highway if it was recessed. So again, the pavement marking materials are the same. However, you'll notice that the anticipated life expectancy of the materials has greatly increased. Again, because we have that entire material in a recessed slot below the final surface of the pavement. You also notice that some of the annualized costs stayed the same or were actually reduced. Again, these annualized costs do include the cost of recessing the slot or the groove in the pavement that the pavement marking material is applied to. But this is a good illustration that shows that we can increase the life expectancy of pavement marking materials that are recessed, but you also get a long-term cost benefit by having that increased life expectancy, even though initially you may have a higher cost because you're having to pay to install that recessed groove in the pavement. One other thing we want to point out about the selection guide, when you look at the recommendation guide for striping on new concrete, you'll see that there are some boxes that say no surface application. Due to the large return on investment for adding the recessed groove to a new concrete surface, placing a marking on the roadway surface on a higher ADT roadway in northern and central Illinois is actually not recommended. We would always recommend that you try to recess pavement marking materials on new concrete surfaces if possible. Another aspect of the selection guide were the tables specific for maintenance striping. So again, this is striping where you're refreshing an existing pavement marking material or you're applying new pavement marking material to an existing pavement surface. So for the selection table for asphalt surfaces, we further break down the pavement marking material recommendations based on the anticipated service life of the pavement. So for asphalt, we have a separate category for pavement service life that's less than or equal to 5 years, and for pavements that have an anticipated service life of over 5 years. We also do the same for maintenance striping on concrete surfaces. However, the cutoff between the different tables is based on a pavement service life of 10 years rather than the 5 years that we use for asphalt. So the costs shown in this presentation and in the final report of the research are actually based on 2013 average unit costs. The unit costs that are developed in our own internal policies, as well as the pavement marking selection, installation, and inspection manual, were actually updated based on 2014 and 2015 unit cost data. And actually, we plan on keeping these recommendation tables up to date on a 2-year cycle. So we will actually be reassessing all of these recommendation tables again later in 2017 based on the new cost data. And I will point out that there were some changes between the 2015 data and the 2013 data. So if you're wanting to look at the most up-to-date recommendation tables, we would recommend that you look at the tables in the pavement marking selection, installation, and inspection manual, which can be found on IDOT's internet webpage. So again, the final report, the current guide and manual, as well as IDOT's own internal TRA 14 departmental policy, all contain these recommended pavement marking selection tables. They can also be found on ICT's website. And again, I would recommend, if you're wanting the most up-to-date recommendation tables, you would need to look at the current inspection and selection guide. And for those IDOT employees, you could also find the most up-to-date tables within the departmental policy TRA 14. And with that,
Great.
I
Well,
will
thank you.
turn it back over to Carmen.
Great. Thank you very much, Kyle. Appreciate the thorough explanation of the guide and the research. Before we begin the next poll question, I want to remind everyone that if you have any questions for Kyle or Anna here in a minute, please feel free to type your questions in the question pane of the control panel. So for our first poll question, the question is, how many times have you observed or inspected the installation of pavement markings? The options are never, 1 to 10 times, more than 10 times. Please select the appropriate response and click Submit. We will publish the results here shortly. These questions will help Anna have an idea of the background of the audience for her presentation. And here's the results. So we have, I guess, our strongest or highest percent of participants in the 1 to 10 times for inspecting pavement markings, with a fairly large group also at more than 10 times. So our next question, how did you hear about the webinar today? The options are IDOT's website, an email invitation, Facebook or Twitter, word of mouth, or by some other method. And this helps us have an idea of how our announcements for the webinar are reaching everyone. We'll publish those results in just a minute. Okay, so we have our highest percent having heard about the webinar through the website or an email invitation, with a few more by word of mouth. So now I'm going to hand the webinar over to Anna for her presentation on pavement marking, installation, inspection.
Thank you, Carmen. For markings to reach their expected service lives, as Kyle described in his presentation, they must be installed properly. At the back of IDOT's pavement marking selection, installation, and inspection manual are several inspection check sheets for materials currently approved for long line pavement markings, as well as one inspection sheet for installing a groove for recessed markings. Criteria listed in these check sheets comply with IDOT standard specs for road and bridge construction. For this portion of the webinar, I'll be describing recommended tests and measurement tools for several of the inspection items. Before we cover the tests and measurement tools, let's review some of the major factors that can affect the proper installation of pavement markings. Ambient and pavement temperatures are important because most pavement marking materials require a minimum temperature to achieve proper drying or curing. Material temperature must remain constant so that the material's viscosity remains constant. If the viscosity changes, then the material application rate can be affected. And of greater consequence, the mix ratio of plural component pavement markings, such as epoxy, polyurea, and modified urethane, will be altered. Pavement surface moisture at the time of the application can prevent the marking material from sufficiently bonding with the pavement surface, and wind velocity can affect the application of drop-on reflective media. High winds can cause the reflective media to be poorly dispersed or from reaching the binder material altogether. Material applied too thin will not provide a sufficient substrate for the reflective media to bind, and the beads may sink in the material when it's applied too thick. Here is an example of a pavement marking inspection kit and a list of the recommended tools for the kit. In the next few slides, I'll cover the tests that can be performed with these items. First, for the pre-installation, we're going to talk about grooving depth. To assess whether a groove depth is within the allowable range, an inspector will need two plates that are narrower than the groove width and a straight edge that is wider than the groove width. One plate should be the thickness of the minimum allowable groove depth, and the other plate should be the thickness of the maximum allowable depth. The measurement steps are: place the thinner plate in the groove and lay a straight edge over the plate. If the straight edge rests on the plate and does not touch the pavement, then the groove is too shallow. If the straight edge rests on both the plate and the pavement, or on just the pavement, then the groove depth meets the minimum allowable depth. Place the thicker plate on the groove and lay a straight edge over the plate. If the straight edge rests on the pavement and there is a gap between the plate and the straight edge, then the groove is too deep. If the straight edge rests on the plate and the pavement, or on just the plate, then the groove depth does not exceed the maximum allowable depth. I'm going to show two videos. This one right here is a picture of a grinding truck, because typically sometimes we don't always groove everything. We're going to remove the existing pavement marking. And here's an example of the grinding truck. You can see that it's not 100% removal, and you can also see that it's causing some damage to the concrete pavement it's on. But one thing we have found within our district is that we like to use this method on a concrete surface because it roughs up the surface and it allows the new pavement marking to stick to it better. Okay, the next video is going to be a video of water blasting. And as you can see on this one, you are going to get 100% removal of the material. But one of the unfortunate things with this method is now that the pavement is wet. So if you're following the guidelines here for pavement marking installation, you're going to have to wait 24 hours in order for the new marking to go down. And you can see that there's not as much damage to the pavement. Another test is to verify if the pavement surface is clean. To do this, you're going to do the surface wetting test, which requires using an eyedropper, placing a drop of clean drinking water on the pavement surface. If the drop forms a bead, then the surface may need to be re-cleaned. If the drop spreads out, and the surface is ready to accept the application of marking. Next, you're going to check for surface moisture. If moisture is present in the pavement surface, then it may prevent the marking from bonding to the pavement. The surface moisture test is a method for determining whether the pavement is dry enough to accept application of the marking material. The test steps are: number 1, place a 12-inch by 12-inch piece of plastic wrap on the pavement surface and tape the edges. Leave the plastic wrap for approximately 15 minutes. After 15 minutes, check for moisture bubbles inside the surface of the plastic. If the moisture bubbles are larger than a pencil eraser, then the pavement has too much moisture in it. This pre-installation test method is particularly important for thermoplastics because the heat of the thermoplastic can pull moisture up to the pavement surface. And of course, we want to measure pavement surface temperature. You're going to go off the standard specifications for temperature for installation based on the marking material. Then you're also going to measure the material thickness. Markings with a required wet film thickness of 80 mils or less should be measured with a wet film thickness gauge. Prior to installation, a contractor should place a test strip without the glass beads at a calibrated travel speed with the wet film thickness should measure on and the wet film thickness should measured on the test strip. To measure wet film thickness, press the edge of the gauge vertically into the wet material. Withdraw the gauge and note that the deepest tooth with material on it and the next higher tooth that is not coated with material. The wet film thickness lies between these two readings. Next is to verify the calibration of glass bead application. Most glass bead application rates are given in pounds of beads per gallon of the specified marking material. To ensure that beads are applied at the specified rate, the bead guns must be calibrated prior to the marking installation. Verify that the calibration is performed is an inspector's best opportunity to ensure that the rates will be met. To calibrate bead guns, the desired travel speed must first be known. Then, while the striping truck is stationary, beads are sprayed into a container for a predetermined amount of time, usually for a few seconds. The beads are then poured into a graduated cylinder and the volume of beads is read. The volume of beads should correspond to the required application rate for a given travel speed. For example, to place 10 pounds of type 1 glass beads per gallon of material while traveling 4 miles per hour, the volume of glass beads collected during a 15-second spray should be 1,200 milliliters. If the volume is too low, then the bead flow needs to be increased. If the volume is too high, then the bead flow needs to be decreased. The table here is a bead gun calibration chart for a 10-second spray of type 1 beads being placed on a 6-inch wide marking with a 15 mil wet film thickness. Bead calibration charts for other bead types and other marking material widths and thicknesses may be acquired from material manufacturers. Okay. For an example for test during installation, you want to verify whether tape is being tamped down. So in the first picture here, you can see that they're installing the preformed tape, and on the second one, you can see that they're using a tamper, and you should verify whether it's 200-pound load that's being tamped, and you should also look within the standard specs to see how many times it's recommended for it to be rolled. Once the marking has been installed, you want to verify the glass bead dispersion and retroreflectivity. Although IDOT specifications do not require a minimum retroreflectivity, markings are required to be retroreflective. Therefore, the sun over-the-shoulder test from Texas DOT test method TEX-828-B can be used to assess retroreflective properties. The test steps are as follows. First, when the sun is between 20 and 80 degrees above the horizon, position yourself so that the sun is behind you. View the stripe in front of you along a plane parallel to your shadow. Adjust your distance from the stripe to where the shadow of your head touches the stripe are being observed. From this position, evaluate bead dispersion and retroreflective qualities of the stripe. Glass beads will provide an optimum retroreflectivity if they are properly embedded in the liquid marking material. To achieve optimum retroreflectivity, 50 to 60% of the bead diameter should be below the surface of the marking material. A magnifying lens can be used to examine the depth of bead embedment and bead dispersion. Also, post-installation, you're going to want to measure your marking width and the joint offset, which is meaning how far away from the joints, from the edge of pavement, and from the longitudinal center line you want to have your pavement marking. The required distance is greater than or less or equal to 2 inches. Our problem within our district is that we're finding that when it's along the center line, that's one of the first areas to fail. And so we're pushing residents to move their markings away from that centerline joint. Finally, I'm going to show a video that demonstrates proper pavement marking using a truck. And here you go. As you can see, it's going to be a 3-gun system. The first gun is shooting the liquid marking, followed by the next 2 guns placing the beads. This is also referred to as a double drop of beads.
So thank you, Anna. Appreciate the video demonstrations there as well. Thank you, Kyle and Anna, for your presentations. Before we begin the Q&A, I would like to let you know about the 2 previous recently completed webinars. A recording of the first webinar, Modified Right Turn Lane Design, is available at the Illinois DOT's YouTube page shown here. And the recording of the second webinar, Flashing Yellow Arrow at Intersections, will be available soon. And a public service announcement video that was shown during the webinar is currently available at the second address shown here. So to make these videos easier for you to access, the links will be sent to all attendees via email. Okay, so I'm going to begin our Q&A session here. We have a few participants that have submitted some questions. First of all, I want to let everyone know that the presentation slides will be available to all participants. They'll be sent out via a link, as you saw on the previous slide. So then everyone will have that, as well as the audio recording. So I'm going to begin with the first question that was submitted. This is for Kyle. Decatur, Illinois just recently did a pavement marking job on a new overlay. They used the inlay recess method. It looks to be quite an aggressive recess. Question is, it seems like this method would hold water and ice and possibly obscure the visibility. Your thoughts?
So yes, that is a potential concern when you recess different pavement marking materials. One way to combat that is to make sure that the depth of the groove is appropriate for the pavement marking material that you've selected. I believe the special provision that we use specifies 40 to 80 mils for liquid markings, and then for the thicker marking materials such as the preformed plastic and the thermoplastic, the depth should be 100 to 200 mils. So basically with those depths, we're trying to make sure that the entire thickness of the material is below the final surface. But again, we don't want the recessed groove to be so deep that water can't potentially pond within the groove and obscure the visibility of the marking material. But again, you also have to weigh the potential benefit of recessing the material, because you're going to greatly increase the lifespan of that material by keeping it below the surface of the pavement.
Okay, great. Thank you, Kyle. I think this next one's for you as well. Was there any thoughts on doing variable sizes of reflective elements or beads to allow for better or higher reflectivity in the rain?
So we actually had a research project where we were evaluating wet reflective elements within different types of materials, and we are actually continuing that research, kind of phase 2 of that research, to reevaluate some of the pavement marking materials and wet reflective elements. So we are looking further into that. It was not a part of this particular research, but it is part of a separate research project that is ongoing.
Very good. So we'll need to stay tuned for that one. So the next question, this is for Kyle. This question is for Kyle. When applying pavement marking via recessed process, is the cost of recessing the pavement included in the cost of the pavement marking, or is this a single pay item?
Okay, for contracts, for construction contracts, we actually have a separate special provision for the recessing of pavement markings, and it is a separate pay item. So for those of you who are familiar with IDOT contracts, it's actually contained in a BDE special provision, which you would just include into your contract to specify to the contractor that they are to recess the pavement marking materials into the contract. And there is a separate pay item for that. So you would have your pay items for the pavement marking materials, and then you would have a separate pay item for the recessed groove. Now for this research, again, I want to point out that the annualized cost data that's contained in those recommendation tables for the recessed portion of those tables, those costs do include the cost of recessing along with the cost of the pavement marking material. But for your specific question on contracts, the pay items are separated.
Okay, great. Thanks, Kyle. Next question, does the guide give guidance on when pavement marking tape, type 3 versus type 4, should be specified in work zones?
Okay, I think that's my question as well.
Yes.
The pavement marking tape, type 3 and type 4, those are temporary tapes in accordance with the spec book. And we did not include temporary materials as part of this research project. And for those of you who may not know, a pavement marking tape type 3 and type 4 are very similar. It's just that type 4 actually has those wet reflective elements included. At this time, we do not have specific guidance on when to use type 3 or type 4. We are working on that, and when that is issued, it will probably be included with our internal TRA 14 departmental policy. But we would also relay that information to various local agencies so that they could use it for their own contracts if they wish.
Okay. Thank you, Kyle. I have a question here for Anna now. Question is, where is grooving for recessed markings covered in standard specs, and how is it paid for? I assume this is one Anna can answer. If not, we'll forward it to Kyle.
I can answer it, I think. It's in the standard spec book under the 700 section for pavement marking installation, and it's paid for separately as it's got its own pay item number.
Great, thank you, Anna.
Kyle can answer any more if he wants to.
Okay, well, I think that covered that. This next question is back to you, Kyle. I believe you might be able to answer this directly from the guide, but the question is, what's the life of the preformed thermoplastic in the recessed installation?
Okay, I think first we want to make sure that we're using consistent terminology here, because there can be some confusion with the different pavement marking material types. There's thermoplastic, preformed plastic, and then there's preformed thermoplastic. Thermoplastic is applied directly to the pavement in a molten condition. It's literally heated up and applied in a molten state, and then when it cools, it hardens and cures to the pavement. A preformed thermoplastic is a material that it actually comes in pieces and you actually fit them together kind of like a puzzle, and you apply them to the pavement surface and then you heat them up with a heat gun so that way they melt and then they cure onto the pavement surface. Specifically for preformed thermoplastic, we did not include that material as part of this research. It's a material that's not used very often because it's really only limited to transverse markings like stop bars, crosswalk lines, turn arrows, and some of the newer route shields that we've been installing around the state. If I had to guess, if it performs similar to a preformed plastic in a recess, you're probably going to be getting anywhere from, say, 6 to 9 years worth of service life.
Okay, great. Thank you, Kyle. So the next question, this one's for you too. Are there any other considerations for recessed pavement markings such as posted speed limit or added maintenance to make sure the groove doesn't get filled with dirt over time?
Other considerations for recessed pavement marking, actually the districts have been going more towards recessing all types of pavement markings whenever possible and whenever the cost allows. It's particularly good for expressways, freeways, and higher speed facilities. I know in the past when we've applied thermoplastic to freeways and expressways, oftentimes that material can get damaged because it's so thick, and therefore it can be more easily damaged through snowplow operations. But if you're able to get that material completely in the recessed groove and get it out of the way, then you're obviously going to be increasing your service life. So really more and more we're starting to recommend recessing your pavement markings as much as possible, as long as you can fit the additional cost of recessing within the budget of your projects.
Okay, thank you, Kyle. Here's another potential research question. Has there been any research on doing recessed striping on symbols or just longitudinal or long line markings?
So, Carmen, correct me if I'm wrong, but I believe all the test sites included just longitudinal pavement marking. I don't believe we did much research for the transverse markings. And I think there's also some question as to the benefit of actually recessing transverse markings. That's something we would need to look into further, and it's possible we could maybe have further research to look specifically at how transverse markings hold up through both surface application as well as a recessed application.
Okay, yep. So correct, we did not do any tests on the letters or symbols, and even the long line markings we did, the vast majority of them were edge line markings, just to remain consistent and having as few variables in the study as possible. I wanted to point out we did have one question about putting the YouTube links that were on the last slide in the chat box, so I posted those there for anyone who would like to get them now. Moving on to our next question. This participant states, I may have missed this, but how was the threshold of 7,000 ADT for high-low selected for the pavement marking selection table? Kyle, if you want to address this, if you recall. If not, I could probably speak to it.
I'm trying to remember exactly how we came up with that. And Carmen, I don't know if you had the background information on that.
Yeah, so we had originally set it at 10,000. Just felt that would be a good number. And then as we started collecting data on the potential sites, there tend to just be a natural break, if you will, just based on the numbers of sites we were finding that were less than 7,000 or some that were greater than. So that ended up being the threshold. It just seemed that that's where the number of sites were lending us to be able to have a nice distribution between high and low was around that 7,000 ADT. Okay, we have a few more questions. Well, we have time. I'm going to keep bringing them to you. Says, DuPage County is considering the use of spray thermoplastic. Do you have any information on this application, or have you heard of others having success with that? Hey, Anna might be able to address this. Anna, you want to try this one?
I can try. In this district, we have not used it. I know the city of Peoria has used it in the past. They had an unfortunate incident with their truck, so they have now switched over to, I believe, modified urethane truck. But there are some other districts that do use that, and we have specifications within our, I think within our standard spec book that cover thickness and all that of what's supposed to be laid down.
Great, thank you.
I would.
I think I'm going to. Oh, sorry. Go ahead.
Carmen, I just wanted to talk a little bit more about the hot spray thermo. We do include it on maintenance contracts, and we do have our own special provision for that material. From IDOT's perspective, it's really only intended to be a maintenance type of material where you're actually spraying it over some existing thermoplastic that has degraded or has faded. It's not really intended to be applied to a new surface or be a new pavement marking material. It's really only meant to be a maintenance material.
Okay, thank you, Kyle. This next question could be for Anna or Kyle. It says, it appears that recessed markings are usually less expensive than surface markings on an annual basis. Is there any negatives to installation or times that recess should not be used? Have you found any negatives with it?
I could probably address some items. It may have a reduced annual cost, but again, you have to account for that initial cost. You have to determine your own construction budget for your particular project and make sure that you can handle that initial upfront cost of both recessing the groove and of the pavement marking material itself. But again, if you can, it's a good idea because you do have that lower annualized cost for your pavement marking installation. The other scenario I could think of is the condition of the pavement itself. You certainly don't want to be trying to recess a groove in an older pavement that's not in good condition. And also one other thing to consider, in our special provision for recessed grooves, we actually require that the grooving operation does not start until at least 14 days after the HMA surface is applied. So you've got a 2-week wait time to allow that asphalt surface to strengthen and to be able to support the grooving operation itself. So you also have to take that into account, that it could add a little bit of time to your particular project.
Okay, thank you, Kyle. Next question is, have pavement marking types been tested on specialty pavements such as latex concrete? Kyle, it's probably for you.
Yeah, the test sites that were selected, to my knowledge, they were all just standard asphalt or concrete surfaces. I don't believe we have tested or looked at data specific to materials that are on more of the specialty pavement marking surface types.
Right, for this research project we didn't. It was all traditional asphalt, concrete. The only probably unique pavement type might have been a stone matrix asphalt, asphalt pavement. So another question, I've noticed expressway lane lines in Wisconsin that use an apparent black background under the white lane line. This is called a contrast marking. The visibility of the lane lines seemed improved, particularly in wet conditions. Has this been used or evaluated for use in Illinois? So contrast markings, is there any consideration for that?
Yes, we have tried contrast markings in various locations in the state, particularly for concrete surfaces, just to, again, provide contrast to make those white pavement markings more visible. We are working on a special provision to allow that. I hope to get that out soon, and so when that is released, then the districts and the local agencies would be able to use those pavement marking materials as they determined that those would be required.
We've actually used that in District 4 on our new I-74 155 project, and we found it very helpful because there's some joint issues and temporary pavement markings that were left lines from the removal of those, and it looks very well out there. So if anybody wants to come look at I-74 and 155, they did a great job.
Great, that's a nice real-world experience here in Illinois. Appreciate that, Anna. I think I probably know the answer to this next question, but I'll ask it. It's probably for you, Kyle, but how is grooving completed for letters and symbols by machine or by hand? I'm going to assume that IDOT's not currently recessing any letters or symbols. You confirm that, Kyle?
We ourselves are not recessing the transverse markings. It can be allowed through contract. Typically, when we're recessing like an arrow or letters and symbols, we would have the recessed groove actually be a square pattern that encompasses the entire area of that symbol. I have heard of one district trying to actually recess a slot that matches the shape of the symbol. I think it can be done, but that seems to be very difficult to do to make sure that you're getting the proper depth and the proper shape of the symbol. So if you are recessing letters and symbols, I think it would be easier just to recess a square or a rectangular shape so that the entire symbol is within that recessed area.
Okay, great. Thank you, Kyle. Next question. So did the study cover pavement markings applied directly onto rumble strips or rumble lines?
I don't believe that it did. I believe all the pavement markings were applied to just the standard pavement surfaces. And I don't believe any rumble stripes were included.
That is correct. For this study, we did not do that. However, there's been plenty other research done on rumble stripes. You could probably look that up as other examples for reference on rumble stripes. Next question, when pavement markings are being applied to an intersection or areas where a hand-rolled thermoplastic cart is being used, are there acceptable alternative methods to a glass bead gun to apply the glass beads? I think this question's asking is, I'm not sure if they're trying to say that maybe the marking beads were applied by hand and the cart didn't have a bead gun. Anne, have you have any experience with that? With or without the bead guns?
No, but we've had instances with our own crews where if they've had to do something because they can't get the cart there, they'll throw the beads on them. they will hand throw them. But then you have to be careful and watch how you're doing it, because you can leave just lines and not get the right embedment and things like that. So you want to make sure if they're doing that, you're looking for that right dispersion of the glass beads.
Okay, thank you, Anna. Next question says, have you experienced any problems with epoxy on new asphalt pavement as the marking cures and shrinks? And what is the curing time on asphalt pavement before it can be marked with epoxy? So problems with epoxy and then curing time for epoxy. Curing time of the asphalt.
Curing time of the asphalt, we wait 14 days for that. Is that for when before we place the epoxy? And I haven't seen any issues. I have not had any issues with epoxy on new asphalt.
Okay.
Yeah, I'm not aware of epoxy issues on new asphalt. I believe there have been some with polyurea, because when the polyurea, when it cures, it actually attaches to an asphalt surface very strongly, and the different materials can expand and contract at different rates, and that can actually cause stress on a new HMA pavement. It's one issue we've seen before with polyurea. I have not seen that with epoxy. The only issue that I'm aware of with epoxy in the past is sometimes for the white epoxy, it has a tendency to, the color has a tendency to dull over time, maybe turn gray. That's been a potential issue. Also, epoxy is not generally a good material to use for transverse markings. It's more of a longitudinal long line type of marking material. But as far as epoxy causing stress or issues on our new HMA surface, I'm not aware of that.
Okay, thank you, Kyle. This next question says, is there a hand method for recessing markings? And have you had success with controlling, I guess success or failures with controlling the depth of the groove? Familiar with any hand methods for recessing?
I've seen where they've used little carts and hand grinders, and yes, we've had issues with watching the depth. Sometimes they go too deep and you can see where it's gouging and then it's uneven. You've got strips down the center if it's like a 24-inch line that they're trying to groove in. So you're trying to make it even across, and you'll see you can see where each pass that they've made. So it's something that you've got to watch closely when they do that.
Okay, great. Thanks, Anna. Next question, has there been any consideration on the design of the pavement markings so they won't be so slick for cyclists if it's wet outside?
So,
friction question.
Right. We had talked about the preformed thermoplastic a few questions ago. Our spec book actually requires a certain friction level for that type of material. So the preformed thermoplastic material is good for use within bike lanes, and the recent allowance from FHWA for the green colored pavement and bike lanes, a lot of that green pavement is actually green preformed thermoplastic, and that material comes with individual elements that increase the friction of that material. So there are certain materials that have elements in them to increase the friction level as opposed to other materials like thermoplastic or standard paint, which can actually be slick, especially for bicyclists in wet conditions.
Okay, thank you, Kyle. This next question is, directed to you. It says, Kyle, is it recommended to use recessed thermo within turn lane areas, such as lane lines, arrows, edge lines, even if using paint for the remainder of the job and stop bars?
That is certainly an option, although using recessing for transverse markings and for letters and symbols, I think I would like to see a little bit more evaluation of that before I would make the recommendation that yes, all those markings should be recessed. I mean, like I said, thermo is definitely an option, but one thing you want to consider with thermoplastic is it is a very thick material. So if you apply it especially for transverse markings like stop bars and crosswalk lines and your letters and symbols, they are going to be highly susceptible to snowplow damage or just standard vehicular wear and tear because they're going to be out in the middle of the lane as opposed to being an edge line which doesn't see as much potential damage. So I can't really say I would fully recommend recessing transverse markings, although it is certainly an option, but I'd like to see a little bit more data and a little bit more evaluation on that before I can make a definitive recommendation for you.
Okay, thank you, Kyle. Next question. We have just a couple more. We still have a little bit of time, so we'll go ahead and take these other questions. It says, what do you recommend for pavement marking lines over a rumble strip? What product do you recommend for rumble strips?
Anna, I don't know if you've done much rumble stripes in your district. I mean, it's
No,
something, you're probably going to want to go with a liquid marking. So I would probably start with the highest rated liquid marking in the recommendation tables based on, again, your surface type, region of the state, ADT. Based on those tables and try the highest rated liquid marking, which would be, it could be paint, or if you're wanting something more durable, it could be the polyurea or the modified urethane.
Okay, thank you, Kyle. I think this is our last question, and before I read this, we did have one other request to post the site for the guide. And if you go to, I just posted it for all in the chat box. It's the ICT website. You can find that as well as the manual and the entire research report at ICT's website. I posted that again for you there in the chat box. So last question here says, if I might ask an off-topic pavement marking question, I've seen orange temporary pavement marking tape used in Wisconsin. Is that a standard option? It proved to be especially visible at night. I can begin the answer on this. I've actually read a research paper on this. It's a marking they're trying for designating construction zones. So Kyle or Anna, if you know any more about it, feel free to address that related to as it pertains to Illinois.
I'll let Kyle answer that one.
Okay. Orange pavement markings are actually not in compliance with the MUTCD. The markings have to be either white or yellow. But what agencies are allowed to do is they are allowed to experiment through FHWA to try a new type of traffic control device, and in this case a different colored pavement marking for possible inclusion in future versions of the MUTCD. So Wisconsin actually filed a request for experimentation with the FHWA to try these temporary orange pavement markings. I have not seen the results on the research for this yet. I assume it is still ongoing. But if there are positive benefits to the experiment, then it is definitely something that FHWA can include in the future editions of the MUTCD. Until then, technically we would not be allowed to install the orange pavement markings at this time unless we wanted to do our own experimentation with them.
Okay, great. Thank you very much, Kyle. And that concludes our last question, and it concludes our webinar. I'd like to thank everyone for attending today. For additional questions and comments, please contact the DOT at dot.bmpr.research@illinois.gov. Thank you again, and everybody have a great day.